So we're going to have a look in this lesson at resistance in circuit. So what is resistance? Well, every material has an electrical resistance, and a resistance reduces the flow of charges, the flow of current. The symbol for a resistor is this diagram here, and the symbol for a variable resistance where you can change the resistance is shown as this diagram here. Very similar, but with an arrow through it. Now, glass normally has a resistance of 1 million times greater than copper used in electrical circuits. The ohm is the unit of resistance named after school teacher George Ohm. Thin or thick? So let's think about the thickness and the resistance. Now, a thin piece of metal has more resistance than a thick piece of metal of the same length. So the thinner the piece of metal, the more resistance. Length and resistance. A long piece of metal has more resistance than a short piece of metal of the same thickness. Conductors and resistance. Now, different types of conductor, which are pieces of metal, have different levels of resistance. So the resistance depends on the type of metal, how thick the metal is, and the length of the metal. Let's have a look at current now. Now, current is the flow of electrical charges around a circuit, and remember they're microscopic. And remember, current flows from negative to positive points. We know that from a previous lesson. The current is measured in amperes, A. And current is measured using an ammeter. And we've got the symbol below, an ammeter. So we're going to have a look at the relationship between current and resistance now. Now, to do this, I'm going to draw a circuit diagram. So here I've got a cell, and I'm going to draw a switch. Now remember, when the switch is closed, the circuit is complete and the current can flow right round the circuit. I'm going to draw a bulb or a lamp here, an ammeter to measure the current. I'm going to draw in a resistor. Now what we find is, remember that current flows from the negative to the positive, so that's the direction that the current is flowing. Now what we find is, the greater the resistance, because I've added a resistor, the greater the resistance, I find that my bulb is dimmer. And this is due to a smaller current flowing round the circuit. The resistor causes a smaller current to flow round the circuit, and this can be measured using the ammeter, which measures the flow of charges, the current. Now we're going to look at a variable resistor. The symbol for the variable resistor is the same as the resistor, except we have an arrow through it. The relationship between the length of the material and the resistance allows us to make a variable resistor. So remember, the greater the length, the greater the resistance. The shorter the length of wire, the shorter the resistance. So here we've got an example of a variable resistor. So in the diagram, if we were to move the slider, which is shown here, from A closer to B, what we're doing was we're increasing the length of the wire every time it moves closer to B. And the greater the length of the wire, the greater the resistance. So if the slider is moved from A to B, the resistance will increase because the length of the wire has also increased. By moving that slider from A to B, we're increasing the wire that's included in our circuit, so we're increasing the resistance. So what are the uses of variable resistors? Well, they can be used as volume or brightness controls in televisions, volume control on MP3 players, light dimmer switches. Because remember, the greater the resistance, the less current, so the dimmer the bulb. So the variable resistor. Resistors in a circuit can be used to slow down the currents, slow down the charges. Some resistors have a fixed value. Now others, for example variable resistors, can be used to change the current in a circuit. Now why is this going to be useful? Well, they can be used in dimmer switches and to control the volume in a stereo. So are we able to recognise the circuit symbol for a resistor and remember a rule about current and resistance? Let's do some questions now. The cell stores what kinds of energy and transfers it to what kinds of energy when a circuit is connected? The cell stores chemical energy and transfers it to electrical energy. An electric current is a flow of microscopic particles called electrons, and current is measured using an ammeter. And remember, the symbol for an ammeter is A. In which direction does the current flow? Well, the current flows from the negative terminal to the positive terminal. What's this the symbol for? A resistor. What's this the symbol for? A variable resistor. So what I want you to do now is draw a circuit containing a resistor, a cell and a lamp. So grab your pen and paper and have a wee go. Now remember, you can pause this video for a moment or two to allow you to do the task. So let's do this together and then we'll check our answer. Now, what was the symbol for a cell again? Well, we had a straight line, thin straight line, a thicker line here. Then we're going to draw wires in. I wanted a lamp and a resistor. So I'm going to draw a resistor and a lamp. There we are. Right, let's see how the answer looks. Brilliant, we had our cell, our resistor and our lamp all connected. What is resistance measured in? Ohms. Name 3 things that can affect resistance of a material. The thickness, the length, and the conduction. A thin piece of metal has more or less resistance than a thick piece. More resistance. A thin piece of metal has more resistance than a thick piece of metal. A long piece of metal has less or more resistance than a short piece. Well, it has more. A long piece of metal has more resistance than a short piece. Different types of conductors, which are pieces of metal, have different or the same levels of resistance. Well, different types of conductors have different levels of resistance. Now I'm going to put here the greater the resistance, The greater the resistance, the dimmer the bulb. And this allows us to use variable resistors to have dimmer switches. The relationship between watt of the material and resistance allows us to make a variable resistor. So the relationship between the length of the material and resistance allows us to make a variable resistor. So again, if we remind ourselves about a variable resistor, if we were to move the slider from A to B, what we're effectively doing is increasing the length of the wire. So we're increasing the resistance. State two uses of variable resistors. Well, we could have MP3 players and dimmer switches.